Alright, test test, 1 2 test test. Perfect. Now this stream wasn't scheduled. I shouldn't be awake right now, but I am. Anyways, I finished with all my other more boring homeworks and I can finally do my calculus homework. Can't wait to give my new peripheral a try. So today we're gonna be doing integration by trigonometric substitution and by partial fractions. Frankly, I don't quite have a clue what I'm doing, but I'll try my best. I won't have enough time in this stream to finish all 3 sections for last week. We were supposed to have this stream on Saturday, but then my peripheral broke, so now I have to get a new one. But now I'm back, and I got an even bigger, better one. So we'll probably have to cut this into 2 sections, 2 halves. I'll try to finish 7.3 and 7.4 right now. And then later today we can do 7.5. And if I do this quick enough, we'll still have time for another lobotomy corporation stream. Anyways, let me put on some music. And let's get started. This seems like a pretty short section, but from what I know, each one of these problems can take quite a long time. So trigonometric substitution, there's really only 3 formulas. These are not the complete formula. If I remember, there was still bounds to this. There's a lot of weird stuff, but this is all you need to know to do trig substitution. The first question under trig substitution is going to be your number 4, which wants to get the integral from indefinite integral of x squared over the square root of 9 minus x squared dx. And it's easy to see that this part fits into the first case, which is square root of a squared minus x squared. A would be 3 because we have 9. 9 is 3 squared. So if we do the substitution, x would be equal to, or rather, let's write this in a different color. X should be equal to 3 sine theta, and dx would be equal to 3 cosine of theta, d theta. Oh no, I forgot something. Damn it. Shit. Ow. There we go. All right, now I'm ready. So if we rewrite this, if we rewrite the integral, we get 9 sine theta, 9 sine squared theta over the square root of 3 squared minus 3 sine theta squared, as in dx turns into 3 cosine theta d theta. First question starting strong. The question strong, not me. And if we factor out a 3, we can take out the 3 here. So we'll get 9 over 3 times 3. So we'll just have 9 outside. Oops. What did I just do? Oh no. I'm not used to using this thing. What did I just do? Give me a second. We're having some technical difficulties. I've got like 1,000 things running the tray. Okay, now we should be good. So we would have 9 times the integral of sine squared theta cosine theta over the square root of 1 minus sine squared theta d theta. Now 1 minus sine squared theta turns into cosine squared theta. We square root that, we get cosine of theta. Write that down. Sine squared theta cos theta over cosine theta. Of course, cosine theta cancels out d theta. So we're left with 9 times sine squared theta. How do we do sine squared theta? Okay. What's the formula? I think it's 1 half 1 minus cosine of 2 theta. So we get 1 half times 1 minus cosine 2 theta. Hang on, is it a plus or a minus? It's called double angle formula, right? I just need to double check real quick. That's not it. Where's my notes? Oh no. Okay, yeah, it is minus. It is minus. If I have cosine squared, that would be a plus. Sine squared is minus. D theta. Which is equal to 9 over 2 times the integral of 1 minus cosine of 2 theta d theta. So we get 9 over 2 times x minus 1 half sine 2 theta. That would translate to, let's say, how about 9 over 4 times, you know what, let's leave it as is. Don't want to make a simple algebra mistake. First off, I did make a small mistake. That shouldn't be x, that should be theta, not x. Because everything's in terms of theta right now, but we need to plug it back in. So x equals 3 sine theta. That means theta equals to, theta is equal to arc sine of x over 3. So I have arc sine of x over 3 minus 1 half sine of 2 arc sine x over 3 There's a way to simplify this, but I'm too lazy to do it. So I'm gonna leave the answer like this, because I'm lazy. Alright, that's number 4. Now then, hang on. I think that's right. Next up is number 10. Oh yeah, the whiteboard, or should I say blackboard, looks different now. Did you notice? We got a dark background and dark seam calculus. Well, the integral from 2 over 3, between 0 and 2 over 3 of 4 minus 9x squared. So that's still the sign substitution, dx. Alright, this one's a little more difficult. X would be equal to 2 over 3 sine theta. Dx would be equal to 2 over 3 cosine theta d theta. Because 2 over 3 squared is 4 over 9, and that would turn to 4 minus 4 times sine squared of theta. Just like this. And that means we can factor out a 2. From over here we will get 4 over 3 times the integral. We don't know where it starts and ends right now. Don't know until we plug everything back in. 1 minus sine squared theta, that's gonna turn into cosine theta, times 2 over 3 cosine theta d theta. No, I already took out the 2 over 3. Just times cosine theta d theta. No, I can probably skip a step here, because this is cosine theta, this is cosine theta, so this is the integral of cosine squared theta d theta. And because of that, we're gonna have 4 over 3 times integral from there to there, dot to dot, of 1/2 1 plus cosine of 2 theta d theta. So we're left with 2 over 3 times x plus sine 1/2 sine of 2 theta d theta. And then, why did I write x again? As for every single time, I always write an x somewhere, especially when there's a 1. I just automatically think, oh, 1 turns into an x. And here comes the fun part, where we have 2 over 3 times, we're gonna plug theta back in. So theta is equal to arc sine of 3 over 2x. Oh god, I am not doing this by hand. The arc sine of 3 over 2x plus 1/2 times the sine of 2 times the arc sine of 3 over 2x from 0 to 3 over 2. Ooh, don't want to do that. But I feel like I did something wrong, because what would be the arcsine of 9/4? Alright. And I'm gonna let a calculator do my job for me. Oh, how am I going to even enter that into a calculator? S 3/2. Wait a second. Oh crap. Where is it? Oh. Damn, there's so much dust. Anyways, we want... I completely forgot how to use this thing. Or even as fractions. I need a minute to figure this out. I think that's it. What am I missing? Value entered is not allowed in the function. Make sure I'm in radian mode, yes. Hang on. Is arcsine of 9/4 is not allowed. That is a problem. Probably means we have something wrong. I remember seeing a triangle before. Was angle theta. Opposites over hypotenuse. No. Sine theta equals 3x over 2. This is what I'm thinking of. Ooh. I don't think that helps. And what is wrong with this? Wait a second. I think I know. That's not 3 over 2. That's 2 over 3. Why did anybody stop me? So arc sine of 1 would be pi over 4, if I'm not mistaken. We got 2 over 3 times pi over 4 plus 1/2 sine of pi over 2. Sine of pi over 2 is 1. Minus 0. Arc sine of 0. Give me a second. Arc sine of 0 is I'm forgetting. Sine is x. The arc sine of 0 is 0. And sine of 0 is 0. Does that mean we don't need the second half and our answer would just be this? Let me check. Doesn't actually look like it. Might have been a mistake somewhere. Oh, let's see. Calculator. Is this a mathematical error? Uh-oh. That's not helpful. A second. Arc sine of 1 is what? Where's pi? Here's pi. Arc sine of 1 is pi over 2. Oh yeah. Arc tangent of 1 is pi over 4. So it was another mathematical error. So this is 2 over 3 times pi over 2, not pi over 4, plus 1/2 times sine of pi. Sine of pi is 0. So this whole thing is 0. And arc sine of 0 is still 0. So this is equal to pi over 3. Oh god, I have no idea how to use this thing. What did I just click into? I don't know how to get out of here. Haven't used a calculator in so long. Okay. That's another question dealt with. Holy, did it seriously take half an hour to just finish 2 questions? I need a second. This area is so dusty. Next up is 13, which asks for the indefinite integral of square root of x squared minus 9 over x to the power 3 dx. Okay, this is another sign substitution, so x is, wait, no, this is the secant. X equals 3 secant theta. Dx equals derivative of secant tangent. So 3 secant theta tangent theta d theta. Or integral will be equal to square root of 3 secant squared theta minus 3 squared, or the 3 squared secant squared theta minus 3 squared over, draw a straight line please. Ooh. 27 secant cubed theta tangent cubed theta d theta. I feel like I might have missed something. Did I miss entire unit? No, I shouldn't have. My memory shouldn't be that bad. Wait, I did something wrong. I don't know why I wrote that. It's 27 secant cubed theta, and here is 3 secant theta, tan theta, and these are all cubed, d theta. And then these secant cancels out. You bring the 3 out here, so that turns into 1/3 times the integral of secant squared theta. It feels good writing on this thing. minus 1, which turns into tangent squared theta, which turns into tangent theta. We already took the 3 out, so there's no need for that. We can move this down. Like that. And then tangent cube theta, d theta, which is going to be equal to 1/3 of tangent to the power 4 theta d theta. And to integrate that, oh no, how do I integrate tangent again? If I'm not mistaken, we got a 10 squared, and then we have secant squared theta minus 1. That doesn't exactly help. I need to check where's my previous notes. Wait. I think I skipped an entire lesson somewhere. So this is 7.3. Wait a minute. Where's the part that's all about trig stuff? Trigonometric integrals. Wait, what's 7.2? This feels wrong. 7.2 was integration by parts. Why is this 7.2 trigonometric integrals? Is my textbook not the one that's used in class? Anyways, let's find our answers here. Good time to do a little review. Oops, oopsie. Oh, I think my handwriting got a lot cleaner after I got this new thing. So cosine squared, sine squared, we can all do. Cosine to the power 4, sine to the power 4, just a little longer, same thing. Sine of odd power, we take out 1, sine squared. Sine, cosine, sine even, cosine odd, we take out a cosine. Sine odd, cosine even, we take out a sine. Both even, then we would have to do a really weird thing where we have, what do you call it, conjugates? I think that's what you call them. Tangent secant, both odd power, we take out 1 pair of tangent secants. Secant out power, we just do substitution by parts. But I also remember that we should basically just memorize the integral of secant cubed. And I think I have it memorized. And we have tangent squared, then we turn that into secant squared. Wait, I think I'm overthinking this. Where am I? Well, if we were to do that, we'll have secant squared theta minus 1 squared, which would give us secant to the power of 4 theta minus 2 secant squared theta minus 1 d theta. How do I deal with secant to the power 4 again? Do I make that secant squared? No, that doesn't help at all. Need to refer back. Do I have an example on secant to the power 4? I do not. Oh no.
It's too heavy.
Oh, we have here tangent squared x is easy enough to deal with. We'll have tangent to the power 4. Well, time to get help. I just need a little hint. Wait a second. I think I was right the first time, or am I wrong? Yeah, I was right the first time. Should have trusted myself. Why is whiteboard lagging already? I've barely done 3 problems. It's already lagging. Tangent squared theta times secant squared theta minus 1 d theta, which is equal to 1/3 of tangent squared theta secant squared theta minus tangent squared theta, which we can now solve. We want tangent squared theta, forgot the n, secant squared theta minus, let's write this separately, d theta minus 1/3 times integral of tangent squared theta d theta. Now to solve tangent squared theta, secant squared theta, use substitution. U is equal to tan theta. Du is equal to secant squared theta. That means we'll have u squared. Why did I forget the c? I forget at least one letter in every trig function. Trig squared theta d theta. That means we'll have u du. I mean u squared du, which would be 1/2, or rather 1/3 u to the power 3. And if we plug that back in, we get 1/3 times 1/3 tangent cubed theta, and the minus 1/3, we still gotta solve for tangent squared theta. So when we do this, we have secant squared theta. I forgot the c again. Secant squared theta minus 1 d theta, which is equal to tangent theta minus theta. Alright, so we got minus 1/3 tangent theta minus theta. Now what did I forget? Because you can never finish a problem without forgetting something. If nothing, then we could perhaps simplify. Or should we just not simplify and leave a mess? Got 1/9 times tangent of 3. No. Secant theta is equal to x over 3. Secant is 1 over cosine. Cosine is, oh god, adjacent over hypotenuse, so this is hypotenuse over adjacent. This would be our triangle. And this would be theta. So tangent of theta, am I doing this right? Tangent of theta is opposite over adjacent. So I guess x squared minus 9 over 3 cubed minus 1/3 x squared minus 9 over 3 minus, there's the line there, 3 seconds and go. Arcsecant of x over 3. Did I write the plus c in the other problems? Yes, I did. Yes, I didn't forget. Now that's an odd number question, so let's check the answer. Number 13. They simplified the answer. Why do you simplify the answer? What if the answer is simplified? This is still wrong. And where did problems start happening? I just can't do a single problem right. This part seems right. And what's it when I try to plug things back in? What is this? Oh god. This is this looks terrifying. Although you can't actually see what I'm seeing right now. Just know it's terrifying. Which step did it start going wrong? Oh, we could have done a U sub even though this is called a trig sub. That can't be right. Beacon is hypotenuse over adjacent. Tangents opposite over adjacent. This entire thing seems wrong. What is the issue here? Starting from the beginning, take out a 3. There's a 3. Wait. Oh wow. I made a mistake all the way at the very beginning of the question. So now this entire part is screwed. because I made a mistake right here. That's fine, we're gonna do over. So secant cube theta. I somehow wrote that I forgot another c in secant. I for some reason wrote secant cubed when it should have been just secant. One problem ruins your day. Equals 1 over 3. And we have... Let's just skip a step and write a tangent theta over secant squared theta. This and this theta takes one out. This tangent goes in, so we have tangent theta over tangent squared theta over secant squared theta. Now is that right? I don't know. And if it is right, how will we integrate this? Tangents. That's the tangents. Secant cancel out with secant on the bottom. Okay. I think that's right, so I'm gonna try to do this. So we get sine squared theta over cosine squared theta times cosine squared theta over 1 with secant. That cancels out. We're left with 1/3 sine squared theta d theta. I get the feeling it's not gonna be this easy. So it's gonna be equal to 1/3 times 1/2 times 1 minus cosine of 2 theta d theta. So it's 1/6 times x, not x, theta, minus 1/2 sine of 2 theta. And now if we plug things back in, theta is equal to arc secant of x over 3, and then minus 1/2 sine of 2 arc secant x over 3 plus c. There's probably a way to simplify this. There's probably a way to simplify. But am I going to? I do not wish to simplify. But if I do simplify, how would it work out? I'm curious. Let's see if I can actually find out. Simplify. Really? Nothing can be done? I need to know. I have to know. Could not simplify further. That is odd. And it might mean I did something wrong again. One third secant or arcsecant x over 3 is correct. But how does this thing turn to x, the square root of x squared minus 9 over 2x squared? If I were to draw that triangle again, hypotenuse over adjacent is x over 3. Is x squared minus 9. Sine of something. Sine of 2 theta. How would I know what sine of 2 theta is? Is there a formula? Oh, right, there is. Sine of 2 theta is equal to 2 cosine, so minus 1/2. That would just be cosine theta sine theta. That makes so much more sense. So this part would just be cosine of theta adjacent over hypotenuse 3 over x times opposite over hypotenuse x squared minus 9 over x. That gives me this, which is still a little bit away. What else is there? Oh, I didn't apply the 1 over 6 to this side. Because this 1 over 6 needs to multiply over here. That makes a lot more sense. No wonder. So now my answer makes sense. Yes! My answer finally makes sense. And now that we're gonna use cosine sine. Should have done that from the start. Why didn't I think of it? But after number 13, we're heading towards... What is the next question? 15. Fifteen wants to know the integral between 0 and a of x squared times the square root of a squared minus x squared dx. That looks like a sign substitution where x is equal to a sine x because a squared. I have a feeling this is gonna be one of the trickier questions. Because why does it be really tricky or really easy? Dx will be a cosine x. And if we rewrite an integral, I just made I made a really dumb mistake. I don't know what I'm thinking. I'm just writing and I don't know what I'm thinking of. So we get a squared sine squared theta times square root of a squared minus a squared sine squared theta times a cosine theta d theta. Simplify that, we get the integral from somewhere to somewhere of a cubed, or rather a to the power 4, because 2 plus 1 we take out from the square root plus this one. We got 4a times sine 1 minus sine squared turns into cosine squared turns into cosine. So we got a to the power 4 times sine squared theta cosine squared theta d theta. Now how do I do this again? We got even sine cosine. Let's rewrite this. Take a to the outside. We got 1/2 x, no, 1 minus cosine squared, no, cosine 2x, not 2x, 2 theta, times 1/2 of 1 plus cosine of 2 theta d theta. Is that right? Seems right. Which I need to disappear for a moment. Hang on, need to make myself disappear for a moment. And now I'm back. We got a to the power 4 over 4 plus the integral from somewhere to somewhere of, how am I gonna multiply this out? 1, ooh, conjugates cancels out, minus cosine squared 2 theta d theta. That equals a to the power 4 over 4 plus integral from somewhere to somewhere of 1 minus 1/2 1 plus cosine of 4 theta d theta. So that is equal to 1 minus 1/2 minus 1/2 cosine 4 theta. So that's 1/2. No, 1/2 1 minus cosine of 4 theta. And if we were to add the integral d theta, it'll be like that. So we would end up with a to the power 4 over 8 plus the integral summer to summer of 1 minus cosine 4 theta d theta, and gets a to the power 4 over 8 plus theta minus 1 over 4 sine of 4 theta. Wait, where does the plus sign come from? I could be just writing and suddenly random things will start popping in. That's more like it. So now, if we plug our thing back in, we want a to the power 4 cats here over 8 times theta, which is equal to arc sine of x over 8 minus 1 over 4 sine of 4 arc sine of x over 8 and another parentheses. And we want it from 0 to 8. Now if x is 0, arc sine of 0 is still 0. That makes things easy. Which means we don't have to worry about 0. But if we were to plug in a, then we got arc sine of 1, which is pi over 2, minus 1 over 4 of sine of 4 times pi over 2, which is 2 pi. Sine of 2 pi is 0. Therefore, we erase all existence of that. And that's equal to a to the power 4 pi over 16. Let's see. Whoa, I actually got it right first try. That's a first. Next up, we need 21. Do you guys hear the cat? 21's integral from 0 to 0.6. That's what it seems like. Of x squared over the square root of 9 minus 25x squared dx. Double check to make sure I wrote everything correct. Everything is correct. 9 minus 25x squared, that seems like another sign substitution. Ooh, okay. So x has to be equal to 3 over 5 sine theta. Dx is, of course, 3 over 5 cosine theta d theta. Okay, I'm gonna need to disappear for another moment. Disappear. Repair, whoosh. Okay, continue on. We do our substitution, integral from somewhere to somewhere of just realized something. Maybe I should put somewhere to somewhere here too. We want what was I writing? Okay. 3 over 5 squared sine theta, or sine squared theta over the square root of 9 or 3 squared minus, I feel like I'm writing too small. I'm write bigger. It's probably hard to see. The 3 squared minus 3 squared sine theta times 3 over 5 cosine theta d theta. Double check. 9 over 25, yes. That's squared. And seems okay. So we get 3 cubed or 5 cubed. Well, we take out a 3 from the bottom, so we get 9 over 125 times the integral from somewhere to somewhere of sine squared theta divided by, let's see, that's 1 minus sine squared. That turns into cosine theta. And there's another cosine here, d theta. That cancels out. We're left with a sine theta. This is a trick question because this feels a little too easy. Unless I made some other math error and just never noticed. And now I'm paranoid. Anyways, 9 over 125 of times the integral of 1/2 1 minus cosine of 2 theta d theta, which is equal to 9 over 250 times theta minus 1/2 sine of 2 theta. And we want that from somewhere to somewhere, which is equal to 9 over 250 times theta is going to be equal to arc sine of 5 over 3x minus 1/2 sine of 2 times some 2 times arcsine of 5 over 3x that is a lot of parentheses. Now we go from 0 to 0.6, which is 3 over 5. How convenient we have a 5 over 3 in our parentheses. That's 9 over 250 of pi over 2, because arcsine of 1 is pi over 2, minus, yeah, arcsine of 1 is pi over 2 times 2, that's pi. Sine of pi is 0. This is equal to 9 pi over 500. Let's see. Wow, another one correct. Now then, once we're done with 21, we should move on to 27. Wants to know the indefinite integral of x squared plus 2x dx. Let me write bigger. This new board's bigger, so my writing turns smaller. This looks like one where we need to complete the square. So let's do that, complete the square. That would be x squared plus 2x plus 1 minus 1. So that would be x plus 1 squared minus 1. Yeah, dx. And here's the tricky part. This looks like it's gonna be we need to do a u sub first. U is equal to x minus 1. Du is equal to dx. No, x plus 1. What am I doing? So now this is equal to the integral of u squared minus 1 du, which we can now say u is equal to secant theta and du is equal to secant theta tangent theta, right? That will give us integral of secant squared theta and minus 1 secant theta tangent theta d theta. Forgot to write d theta here. Very important. Or is it not important, but it's part of work. And that ends us with statins with tangent squared. So we have secant theta tangent squared theta d theta. Ooh. This means we'll have to do secant theta secant squared theta minus 1 d theta, giving us secant cube theta minus secant theta d theta. Here's the fun part. We have secant cube theta and secant theta. Both of which I barely remember. Secant cube theta would be 1 over 2 times secant theta tangent theta minus natural log of secant theta plus tangent theta. Did I memorize that correctly? Let's check. because I know I have that in my notes somewhere. Wait a second. Did I skip 7.2? Yeah, I think I skipped 7.2. Why did I not do homework for 7.2? No. Getting sidetracked, but I need to check first. Am I supposed to do 7.2? Yeah, I guess I'm doing the wrong section right now. Oh no. It's okay, we're just doing it out of order. We're still gonna do all of them. Anyways, what was I? Trigonometric integrals. I haven't done the homework for trigonometric integrals yet. If I did that, what I'm doing right now would make a lot more sense. 1/2 secant tangent plus. Ah, I missed a negative. Okay, this is fine. It's fine. We just need to change that to a plus and it would be correct. Minus integral of secant should be natural log of secant theta tangent theta. Right. I'm second guessing myself, but I need to check. Where's my notes? Yeah, that's right. Wait, no. No. Plus tangent theta. No, I remembered all of these wrong. Which means I think we can simplify this. We have secant theta tangent theta minus natural log of secant theta plus tangent theta. And now we need to do 2 layers of substitute everything back in. I'm gonna draw my triangle to help me. Just gonna draw it here. That's not a triangle. I want a right triangle. Thank you. This is theta. U is equal to secant theta. So hypotenuse over adjacent. And Pythagorean theorem, this is u squared minus 1. Okay. Time to plug things back in. 1/2 of secant theta is u, tangent is opposite over adjacent, so that's u squared minus 1 minus natural log of u plus u squared minus 1, which is equal to, now we need to plug back in x plus 1, x plus 1 squared minus 1, that would be x squared plus 2x like we had at the beginning, minus natural log of x squared, no, x plus 1, not x squared, plus square root of x squared plus 2x plus c. I need to remember the integral of secant cubed x better. Now let's check. What do we have? Looks like it is correct. 3 in a row. I guess I did struggle with the secant cubed part a little bit. I had to check on that. But next up, and our final question for 7.3 is 29. 29 wants to know the indefinite integral of x times square root of 1 minus x squared. So we've only done secant and sine substitution, but never a single tangent substitution in this section, even though we have it listed there. We don't. Of course it's not going to be this easy. This is x to the power 4 dx. Okay, this looks like another sine substitution, but first it looks like it's a u sub. Let me actually change the color. Questions are white. Notes are gray. That's right. Alright. Let's do u sub first. I'm gonna say u is equal to x squared. Du is going to be equal to 2x dx. That way we get one half times integral of 1 minus u squared. This is secant. Wait. Is this a sine? Not secant. Okay. Du. Right. X. Yeah. If that's it, then this is pretty easy. Let's say u is equal to sine theta. Du is equal to cosine theta d theta. Wait, did I write d theta? I did. I keep thinking I forget something, but then I didn't actually forget it. That means we would have 1 half times integral of 1 minus sine squared theta. Oh, I did miss something. Du. Why didn't I write a u? I keep making mistakes like this. Sine squared theta, cosine theta, d theta. That means we get 1 half cosine squared theta, d theta. So we get 1/4 1 plus cosine of 2 theta, d theta. Integrate that, we get 1/4 times theta plus 1 half sine of 2 theta d theta, and plug everything back in. This is equal to, wait, why did I write a d theta? Hang on, did I write a plus c for the last question? I did. It happened again. I questioned whether or not I wrote the plus c, but of course I did. This keeps happening to me. Anyways, this is 1/4 times arc sine of u plus 1 half sine of 2. Actually, can we rewrite this? I believe we can do this. So if that is the case, And we draw a little triangle. I think we can get a much cleaner answer. Sine is opposite over hypotenuse. There we go. So now we plus sine times cosine. Ooh, clean answer. I like that. Now we just plug back in x squared. And plus c is as the answer. 29. That is indeed the answer. 4 in a row. I'm happy now. Even though I haven't slept in months. Okay. That is the entirety of 7.3. I believe my handwriting has gotten a little bit better. Or at least I'd like to think so. Now I completely forgot about 7.2. So I think I'm supposed to do 7.2, 7.3, and 7.4, but I thought I was gonna do 7.3, 7.4, 7.5. I don't know how that happened, but it did. So we're gonna save space for 7.2. 7.2 is just boring. 7.2 is basically all about integrating sine, cosine, secant, since we kind of already did on 7.3. And I just don't feel like doing it right now. So I'm just gonna go ahead and do some line these up. 7.4 first. 7.4 integration of rational functions by partial fraction. This was a unit that I saw was really cool because the first time I saw the integrals I was like, oh my god, no ways this is possible. But then it is, and it's not even that hard. So anyways, let's get on with it. Don't know if we have time to finish this section. I don't think we do. I'm gonna try to do as many as I can before I have to yeet out of here. First off, we're starting with number 12, which asks for the integral from 0 to 1 of x minus 4 over x squared minus 5x plus 6. And the first time I saw this, I was like, no, how do I do this? But the first step to actually doing this would be to, because the power is greater in the denominator. Oops, forgot about my integral. Power is greater than the denominator, so we're gonna factor out the denominator. I don't know when it was I learned about partial fraction, but I had completely forgotten about it until today, or rather until yesterday. I've completely forgotten that partial fraction was a thing, but I do remember doing it. When was that? That was probably before I sold my soul. Anyways, the partial fraction, x minus 4 over x minus 2, x minus 3 is equal to a over x minus 2 plus b over x minus 3. That's how partial fraction works. And if we're gonna do the next step in partial fraction, x minus 4 is going to be equal to a is missing x minus 3, so we're going to time x minus 3 on top and bottom, and b is missing x minus 2. Now then, we have x minus 4 is equal to ax minus 3a plus bx minus 2b. Then x minus 4 must be equal to x times a plus b plus or let's say minus 3a plus 2b. So here we know that a plus b must be equal to 1 and 3a plus 2b must be equal to 4. Therefore, let's say 2a plus 2b equals 2. 3a plus 2b equals 4. Subtract and we get a equals 2. If a is equal to 2, then b has to be equal to negative 1. Let's see. Yeah, 6 minus 2 would be 4. That's great. So now we can rewrite our integral. Is this lined up? It is kind of lined up. Our integral from 0 to 1 of 2 over x minus 2 plus or minus 1 over x minus 3 dx. And oh, that is clean, because now the integral is really easy. This is just 2 natural log of x minus 2 minus natural log of x minus 3. From 0 to 1. Okay, I really have to do this. Natural log of 1 is 0. So we get natural log of 2 minus natural log of 2 minus 2 natural log of 2 minus natural log of 3. Is that right? Plug in 1, plug in 0. Equals negative 3 natural log of 2 plus natural log of 3. Ooh, this is odd. No, I mean even numbered. I need to check my answer elsewhere. Question is, from 1 to 0, that is going to be equal to natural log of 3 minus 3 natural log of 2. Perfect. This is correct. Wow, is that a 5 in a row? Anyways, after we finish with 12, we're gonna move on towards 15. Oops. Got needs to be in a straight line down. Start here. Okay. 15. 15 wants to know the integral of, well, integral from 0 to from -1 to 0 of x cubed minus 4x plus 1 over x squared minus 3x plus 2 dx. I'm actually quite afraid of this problem because the power is greater in the numerator, which means we might have to do long division, and long division will not be pretty with this. So we'll get x to the power 3 plus 0 minus 4x plus 1 divided by x squared minus 3x plus 2. So we multiply by x here, we get x cubed minus 3x squared plus 2x. Subtract, we get 3x squared minus 6x plus 1. Then naturally we have to have a 3 here, x plus 3, which would give us 3x squared minus 9x plus 6. Subtract, we get 3x minus 5. Is that right? That would mean this is, no, x plus 3. Let's write it below. This is x plus 3 plus 3x minus 5 over x squared minus 3x plus 2. Oh no! I'm guessing that we need to partial fraction this thing. I should have 2 colored for notes next time. Okay, we can do this. This is just 3x minus 5 over, oops, x minus 1, x minus 2. So that means that's going to be equal to a over x minus 1 plus b over x minus 2. So 3x minus 5 is equal to a times x minus 2 plus b, keep clicking by accident, plus b times x minus 1. So x minus 5 equal to x times a plus b minus 2a plus b. a plus b is equal to 3 and 2a plus b is equal to 5. That means a is equal to 2, b is equal to 1. Now we can finally rewrite our integral. Line up right here. Where integral is integral from -1 to 0 of x plus 3 plus 2 over x minus 1 plus 1 over x minus 2 dx. Integrate that, we get 1/2 x squared plus 3x plus 2 natural log of x minus 1 plus natural log of x minus 2 from -1 to 0. Plug in 0, we get natural log of 2 because it's 0, 0, 0, 2. Minus, if we plug in -1, we get 1/2 minus 3 plus 2 natural log of 2 plus natural log of 3. Simplify, we get that's 6 over 2, 5 over 2 minus natural log of 2 minus natural log of 3. Is that right? Wait, what number is this? Number 15. Yeah, that's right. Wow. How many in a row was that? I lost count. Anyways, once we're done with 15, we must move on to 19. 19 wants to know the integral from 0 to 1 of x squared plus x plus 1 x plus 1 squared x plus 2 dx. Okay. This one is a bit more complicated. So let's write out our partial fraction. X squared plus x plus 1 over x plus 1 squared x plus 2 is equal to a over x plus 2 plus b over x plus 1 plus c over x plus 1 squared, if I'm not mistaken. Okay. That means x squared plus x plus 1 is equal to a times x plus 1 squared plus b times x plus 2 x plus 1 plus c times x plus 2. Simplified, or rather, let's write this. If x is equal to 1, I shouldn't write it like Java because it doesn't work that way. x equals 1. Not 1, -1 is a better choice. X equals -1, then let's write it here. 1 minus 1, that's 1 equals -1, that's 0, -1, that's 0, -1, that's c equals 1. And if x equals -2, 0, 0, just square 4 minus 2 plus 1, that's 3, is equal to -2 plus 1 -1 square root of 1, a is equal to 1. Okay, we just need b now. Then we still have to factor out all this, don't we? I don't want to, but we have to. Okay, let's just work off of this, springboard off of this. We got x squared plus x plus 1 equals 3x squared plus 6x plus 3 plus bx squared plus 3bx plus 2b plus x plus 2. Okay, move that over. That's 3x squared plus 7x plus 5 x squared plus x plus 1 is equal to that, plus bx squared plus 3bx plus 2b. Subtract, that's -2, -6, -4. That's so b is equal to -2. We have our numbers now. Now we can rewrite our integral as integral from 0 to 1 of a is 3 over x plus 2 plus b, or rather minus, because b is -2. We got 2 over x plus 1, then plus c is 1 over x plus 1 squared dx. Okay, integrate. We got natural log of, no, I wrote something wrong. That's not a 2. That's a 1. We got 3 natural log of x plus 2 minus 2 natural log of x plus 1 plus, okay, this should be x plus 1 to the power of -1. That would be negative. And yeah, that turns to 1, -2. Okay. So this will be minus 1 over x plus 1 from 0 to 1. Okay, plug in 1. 3 natural log 3 minus 2 natural log 2 Why do I write the absolute value? Minus 1/2. Minus 3 natural log 2. 2 natural log 1 is 0. And 1 over 1 is 1. So that would be 3 natural log 3 plus natural log 2 plus 1/2. What number is this? Number 19. Wait, no. I just realized I made a mistake. That's a negative, so that's minus 5 natural log 2 plus 1/2. And 19, where is it? 3 natural log 3 minus... That is also correct. Okay, we're moving along pretty fast. After number 19, we want to move to number 23. And I need to make sure everything's lined up. We need to write in a vertical line. 23 wants the integral of 10 over x minus 1 x squared plus 9. Dx. This one seems quite tricky. I hope I remember how to do this. First off, partial fraction. 10 over x minus 1 x squared plus 9, and because this thing here is to the power of 2, this will be equal to a over x minus 1 plus b x plus c over x squared plus 9. That would mean 10. Oops. Keep accidentally pressing something. 10 is equal to a times x squared plus 9 plus bx plus c times x minus 1. Factor everything out, or rather, I don't know what you call it when you do this. Plus bx squared minus bx plus cx minus c. So x squared a plus b plus, where's x? C minus b plus (9a) minus c. Is that all the terms? 6 terms? Yeah. So a plus b equals 0. C minus b equals 0. 9a minus c equals 10. Alright then. Let's write this out the long way. A plus b equals 0. Negative b plus c equals 0. 9a minus c equals 10. I don't like this system of equations. Subtract those two, subtract first and second equation, or rather add them together. A plus c is equal to 0. Add these together, 10a is equal to 10. Therefore a is equal to 1. Now we need to solve for b and c. How would I go about doing that? Let's multiply the top by 9. So 9a plus 9b equals 0. Subtract that from, or subtract 3 from this, so we'll get 0 plus 9b plus c equals 0. 9b plus c equals 0. And I need another one. Subtract 2 from this. 10b equals 0. Or multiply that by 9. And add together, 10c equals 0. So b and c are both 0, but that would not make any sense at all. I believe there was a mistake here. Where did things start going wrong? Wait. If a is 1, c has to be -1. I just did something totally extra and wrong. A is equal to 1. C has to be equal to -1 because that. If C is -1, B has to be equal to -1. Because this part. None of these conflict. Yeah, B has to be -1. I don't know why I did what I just did. So now let's rewrite for integral. Must line up, must write in a straight line. Right here. We want an indefinite integral, right? Yeah, indefinite integral of a. Why am I writing a? 1 over x minus 1 plus, or rather minus x plus 1 x squared plus 9. Oh, wait a second. I have to partial fraction this again. Oh no. Okay, I think we got another way of doing this. Actually, let's leave that in. I'll write it in a new line. This is equal to the integral of 1 over x minus 1 minus x over x squared plus 9 minus 1 over x squared plus 9 dx. Hang on. Okay, this is still gonna be quite difficult to deal with. This is equal to natural log of x minus 1. Here, if we do a u sub, this would be don't want to make this mistake, so let me write this out. If want the integral of x over x squared plus 9 u is equal to x squared, du is equal to 2x, so we get integral 1/2 1 over u plus 9 du. So that would mean 1/2 natural log of u plus 9. So 1/2 natural log of x squared plus 9. Minus 1/2 natural log of x squared plus 9. And then comes the bad part. I know this is going to be a tangent. Because 1 over x squared plus 1 is tangent, but we have a 9 here. Oh, what do I do? What if we factor out a 1 over 9? Hang on. If we factor out 1 over 9, that would be 1 over. Factor out a 9 or 1 over 9? I think it's a 1 over 9. Yeah, that. So that'll be. We need the parentheses there. That'll be 1 over 9 tangent. No, arctangent of x over 3. Is that right? This is such a long answer. What question is this? 23. Natural log x minus 1 was 1/2 that. Wait. Wait a second. Something wrong here. We made a mistake. We're not supposed to factor out 1 over 9. we would factor out 1 over 3. Right? Huh? We got x squared plus 9. My brains just stopped functioning. As it was over this thing. Brain stopped functioning. I suddenly forgot what I'm doing. Gone. Integral 1 over x squared plus 9. I just suddenly forgot whatever I was doing. Okay. So where did it go wrong? Let's try this part again because I know I made a mistake somewhere. It should be a 1/3, but I need to know why. U is equal to x over 3. U is equal to 1/3 x. No, D is equal to 1/3 dx, not x. So we get the integral of 1/3 and 1 over 9u squared plus 9 u. Huh. Wait, oh. I know what's wrong. This is supposed to be 3 because dx is equal to 3 du. So that's a 3 and we take out a 9 here. Oh, that goes to 0 over 9, which is 1 over 3. And integral of 1 over u squared plus 1 u, and then that is equal to 1/3 tangent of u, no, arctangent of u. I see, and that's just 1/3 arctangent of x over 3. That makes sense. We just gotta carefully erase this little portion, place our 9 with this 3, and that is right. I am almost out of time. I don't know if I can complete this section. How many more questions have we got? That was number 23. 3 more questions. I just might have enough time. Barely. So let's speed it up. First off, line everything up. This line. Okay. 28. 28 wants to know the integral from, no, the integral of x cubed plus 6x minus 2 over x to the power of 4 plus 6x squared dx. Is that right? That seems to be the question. Alright, more partial fractions. X cubed plus 6x minus 2 over x squared plus 6 is equal to a over x plus b over x squared plus cx plus d over x squared plus 6. Should be this way. That means x cubed plus 6x minus 2 is equal to a x squared plus 6 plus b x squared plus 6 plus cx plus d x squared. A x cubed plus 6ax plus bx squared plus 6b plus cx cubed plus dx squared. Alright, all the cubed. X cubed goes to a plus c plus x squared as b and d. In terms of x, we have 6a plus 6b and wait a minute. No. Then where does my -2 come from? This is not right. Bad. Wait. 6b. A little mistake here. 6a is the only thing we'll have to in terms of x, right? Plus 6b. So from this we know that 6b equals -2. 6a equals 6. B plus D equals 0. A plus C equals 1. So B equals -1/3. A equals 1. D equals 1/3. C equals 0. Logic passes. Then if we rewrite our integral, would have the integral of 1 over x plus or minus 1 over 3 1 over x squared plus 1 over 3 1 over x squared plus 6. Is that right? That will mean we have natural log of x minus 1/3. Ooh. X to the power of -2. Oh. Plus 1/3 x to the power of -1. Plus, see, we have another tangent here. 1/3 root of 6. Well, let me refer to the last problem. Okay, so this will probably be 1/√6 tangent of x/√6. Hang on, did I write plus C? I did. Just happened again. Okay, let's check. Wait, no. This is even number. I need to check manually. Tell me. It looks correct. Wow. That was actually correct. I was like, well, 80% sure that I was gonna be wrong because of how long it is. But no, the answer is that long. So we have 30, no, not 30, 33. 33 wants to know the integral from 0 to 1 of x cubed plus 2x over x to the power of 4 plus 4x squared plus 3. Oops. I'm actually quite clueless how to solve this one. How might we be able to break this down? And you see I could factor out from the bottom? Or do we need a substitution first? I think I know. I can at least rewrite this first. I don't think I've dealt with a problem like this before. So basically, this thing is equal to ax plus b over x squared plus 3 plus cx plus d. I'm almost out of time. Quick, 2 more problems. I have to finish this. Rather, I want to finish this. If we don't actually finish, it's fine. I'm not gonna be late for school to just do an extra problem. So x cubed plus 2x is equal to ax plus b times x squared plus 1 plus cx plus d times x squared plus 3, which is equal to ax cubed plus ax plus bx squared plus b plus cx cubed plus 3cx plus dx squared plus 3d. Ow. x3 plus 2x is equal to x cubed, a plus c plus x squared, b plus d plus x, a plus 3c plus b plus 3d. A plus c is equal to 1. B plus d is equal to 0. A plus 3c is equal to 2. B plus 3d is equal to 0. We can probably conclude that b and d are both 0. 2c is equal to 1, so c is equal to 1/2. A must also be equal to 1/2. Rewrite our integral. We go from 0 to 1 of 1 over, let's write 1 over 2 over here. 1 over 2 x squared plus 3 plus 1 over 2, oops, 1 over 2x over x squared plus 3 plus 1 over 2 x over x squared plus 1 dx. So we get 1/2 times interval from 0 to 1 of x over x squared plus 3 plus x over x squared plus 1 dx. This is going to be one half natural log of x squared plus 3 plus 1/2 natural log of x squared plus 1 under the 1, right? What was that? Times 2x. Seems about right. We plug in 1. We can factor out another 1/2 first. We got 1 over 4 times natural log of 4 plus natural log of 2 minus let's do this way, minus natural log of natural log 1 0, so natural log of 3. And the answer is 1 over 4 natural log of 4 plus natural log of 2 minus natural log of 3. So this is 1/4 natural log of, keep pressing this thing by accident, natural log of 8 over 3. Is that right? 433. That is correct. We will actually have time to finish. Yes. Last problem. Oh, I'm excited. I didn't think we're actually gonna finish. So we're gonna have to leave at least 2 problems for the afternoon. So 49 would like to know the integral of secant squared t over tangent squared t plus 3 tangent t plus 2 dt. Looks hard, but nowhere as hard as it looks. So we would first need to do a u sub. U is equal to tangent t. This way we get a polynomial on top and bottom, so we get a rational equation. Du is equal to secant squared t dt. It's perfect. This way we get the integral of 1 over u squared plus 3u plus 2 du, which we can now do for partial fraction. 1 over u squared plus 3u plus 2 is equal to, let's rewrite this, x plus 1 x plus 2 is equal to a over x plus 1 times, or plus, not times, b over x plus 2. So 1 is equal to a times x plus 2 plus b times x plus 1. 1 is therefore equal to ax plus 2a plus bx plus b. 1 is equal to x a plus b plus 2a plus b, which means a plus b is equal to 0, and 2a plus b is equal to 1. That drives us to the natural conclusion that a is equal to 1 and b is equal to -1. Rewrite our integral. We get the integral of 1 over x plus 1 minus 1 over x plus 2. Not x, not x. This was supposed to be all u. Okay, we'll say here. X equals u. I can't believe I just made all that long line of typo. All of these x's should have been used, but we'll just put x equals u right there, so I don't have to rewrite the whole thing. I'm very short on time right now. U plus 1 plus 1 over u plus 2 du. Not plus, minus. Because b is negative. Now that would be equal to natural log of u plus 1 minus natural log of u plus 2. Substitute or think back in, u is equal to tangent t. So we get natural log of tangent t plus 1 minus natural log of tangent t plus 2 plus c. And that is perfect. All right, we have finished. I like my handwriting now, actually. Having a bigger board is so much better. We have just finished chapter 7.3 trigonometric substitution and 7.4 integration of rational functions by partial fractions. And I am perfectly out of time. Oh, hello, Maya and Rose. Reading was part of work. When does this happen? Oh no, did I miss the entire thing? I was so focused on math, I did not read chat at all. But thanks for stopping by. I must lead myself now. I just ran out of time perfectly. Have a great day. Bye.